Now we move to the next subtopics, which is roots and zeros of polynomials. Definition: a zero of a polynomial Px is a number a such that Pa equal to 0. X equal to a is called a root of a polynomial equation Px equal to 0. In general, if x equal to a is a root of a polynomial equation Px equal to 0, then x minus a is a factor of Px. Every polynomial equation of degree n has exactly n roots. Some of these roots may be repeated. Let's see the first example. Show that negative 4 is a zero of 6x power 3 plus 23x squared minus 5x minus 4. Okay. Firstly, we need to let Px equal to the equation of 6x power 3 plus 23x squared minus 5x minus 4. Okay, to show that negative 4 is a zero of the equation of Px, all we need to do is we just substitute x with negative 4. So, P negative 4. Okay, substitute all of the value of x with negative 4. So, we have here 6 times negative 4 power 3 plus 23 times negative 4 square minus 5 times negative 4 minus 4. And find the answer. Okay, we will have the answer is 0. So, since P negative 4 equal to 0, okay, we can make a conclusion. Okay, therefore, negative 4 is a zero of Px. Next, we want to factorize the given polynomial and write all the zeros. Okay, to factorize this polynomial, okay, firstly, in this case, we need to use method trial and error to find one of the factor of this polynomial. Okay, remember, this polynomial, the highest degree of this polynomial is 3. Okay, so the answer we should have 3 factorized. Okay, so let's try. Okay, by try and error, okay, try to substitute, okay, which number or what number into the given polynomial that give the answer is 0. Okay, let's try. Let's say if x equal to 1. Okay, so here substitute x with 1. Okay, we will have here 2 minus 9 plus 3 plus 4. So the answer here we have 0, right? Okay, since P1 equal to 0, therefore, we can say that x minus 1 is one of the factor of polynomial Px. Okay, to factorize completely, next we need to proceed with long division. All we need to do is divide the given polynomial with factor that we already known just now. Okay, so proceed with long division. So we have here 2x power 3 minus 9x square plus 3x plus 4. Okay, divide by x minus 1. Okay, so here x times what here equal to 2x power 3. We know that x times 2x square is 2x power 3. So 2x square times negative 1 is negative 2x square. Okay, so minus, we have here 0. Negative 9 minus minus 2 is negative 7x square. So bring down 3x plus 4. Okay, next proceed. X times what here equal to negative 7x square. X times negative 7x, right? So here we have negative 7x square. Negative 7x times negative 1. We have the answer is positive 7x. Okay, so 3 minus, operation here is subtraction. 3 minus 7 here is negative 4x, and bring down number 4. Okay, so x times what here equal to negative 4x. Okay, x times negative 4, is it right? So we have here negative 4x. So negative 4. Okay, times with negative 1, we have the answer is positive 4. So subtract, here the answer will be 0. Means no remainder. Okay, as usual, after we do a long division, we need to rewrite in general form. Okay, remember what is the general form? Okay, general form should be in terms of px is equal to qx times dx plus rx. Okay, we know that this is our dx. Okay, here we have quotient. This is remainder. And here is our px. Okay, so substitute, we have here 2x power 3 minus 9x square plus 3x plus 4 is equal to, okay, qx. Qx we have here 2x square minus 7x minus 4. Okay, times dx, x minus 1, and the remainder is 0. Okay, all we want to do is factorize the given polynomial. Okay, if we check here, this is a quadratic function. We need to determine whether we can factorize this equation or not. If we can factorize, so we need to factorize. Okay, if we factorize, can we factorize 2x square minus 7x minus 4? What is the answer? Okay, let's try. Here we have 2x square minus 7x minus 4. Okay, so 2x times x is 2x square. We want here negative 4. So negative 4 here times 1 is negative 4. Okay, let's check. Negative 8 plus 1. So we have the answer here. Okay, so okay, this is our completely factorized of the given polynomial. Okay, next we want to find zeros of polynomials. Okay, from here, actually we can find the roots. Okay, let's find the roots first. Okay, the roots. Okay, to find roots, we just take 2x plus 1 equal to 0. Okay, take 2x plus 1 equal to 0. So x is equal to negative 1 over 2. Okay, so roots are x equal to negative 1 over 2. Okay, next here we have x equal to 4, right? Okay, comma, x equal to 4. And the last one is x equal to 1. But remember, we want to find zeros, not roots. Okay, so rewrite what is zeros. Okay, therefore zeros. are, okay, zeros are the number only. Number only. Okay, this number only without x. So our answer should be zeros are negative 1 over 2, 4, and 1. Okay, this is our final answer. Okay, next. Find the roots. Okay, for the given equation. Okay, so all we need to do is, okay, firstly let px equal to x power 3 plus 3x square plus x minus 1. Okay, so by using try and error, okay, so let's try. Let's say if we substitute x equal to 1. Okay, we want to find one of the factor of this polynomial. So if x equal to 1, if we substitute into the given polynomial, okay, p1 equal to 1 power 3 is 1, plus 3 times 1 square is 3, plus 1 minus 1, right? Okay, what is the answer here? The answer is 4, okay, not 0. Okay, means that 1 is not a factor of the polynomial. So we need to check and try with the other number. Okay, let's try if x equal to negative 1. Okay, so p negative 1 we have here. Negative 1 power 3 is negative 1, plus 3 times negative 1 square is plus 3, and then minus 1, minus 1. Here we have the answer is 0. Means that we can make a conclusion, therefore x plus 1 is one of the factor of px. Okay, next, all we need to do is proceed with a long division, or actually we can also use the comparing method. Okay, but in this case I will show you by using long division. Okay, because before we can find the roots, we need to factorize the given polynomial completely. After we factorize, then we can find the roots. Okay, let's proceed with the long division. Okay, divide px with x plus 1. Okay, so here we have x power 3 plus 3x square plus x minus 1, and we want to divide by, okay, x plus 1. Okay, proceed with a long division. So x times x square here is x power 3, right? So x square times 1 is x square. Okay, so subtract, we have a 0. 3 minus 1 here is 2 x square, and bring down x minus 1. Okay, so x here times what? Equal to 2x square. Okay, x times 2x, right? We have here 2x power 2. So 2x times 1 is 2x. Okay, subtract. Here we have 0. X minus x minus 2x is negative x, and bring down negative 1, and proceed with long division. X times negative 1 here is equal to negative x, is it right? So negative 1 times 1, here we have minus 1. Okay, so remainder here we have 0. And remember, after doing the procedure of long division, we need to rewrite in general form. So we have here, okay, x power 3 plus 3x squared plus x minus 1 is equal to qx. Okay, x squared plus 2x minus 1 and times the divisor x plus 1. What is the remainder? Remainder is 0. Okay, so plus 0. So here we need to check whether we can factorize or not the quadratic expression here. So let's try. Okay, x times x is x squared. Okay, can we factorize? Okay, in this case we cannot factorize this quadratic expression, so we will just leave it until here. Okay, the other, to find the roots we will take, okay, the factor, both factor and equal it to 0. In this case, the quadratic function, we need to use the formula to find the roots. Okay, we will use the formula of x is equal to negative b plus minus square root of b squared minus 4ac over 2a. Okay, so here we have, okay, negative 2 plus minus square root of b squared. So 4 minus 4 times a is 1, c is negative 1. Divide by 2a. Divide by 2 times 1 is 2. Okay, so we have here x is equal to negative 2 plus minus square root of 4 plus 4 is 8 over 2. Okay, here square root of 8, actually we can have from plus minus 4 times 2 is 8, right? So square root of 4, we have here 2 square root of 2 over 2, and the roots here we should have negative 1 plus minus square root of 2 after we simplify. Okay, and remember the other roots is here, we just take x plus 1 is equal to 0, so x is equal to negative 1. Okay, therefore, okay, rewrite back what is the roots. So the roots are, okay, x is equal to negative 1, x is equal to negative 1 plus square root of 2, and x is equal to negative 1 minus square root of 2. Okay, this is our answer. Okay, next we have a note here. When attempting to factorize a polynomial of degree 4, okay, it is necessary to find two linear factors using the factor theorem. Okay, so let's try this example. Okay, we want to determine all the roots of x power 4 plus x power 3 minus 7x squared minus x plus 6 equal to 0. So here we have polynomial of degree 4, that has degree of 4, so means that we need to find two linear factors by using try and error. Okay, let's proceed. Okay, firstly, okay, let px equal x power 4 okay, then by using try and error, we want to find factor of the polynomial. Okay, let's try. If x equal to 1, so we have here okay, P1 is equal to, okay, substitute 1 into the equation of Px. So we have here 1 plus 1 minus 7 minus 1 plus 6, and the answer here we have 0, right? Okay, therefore we know that P1 is equal to 0 means that, okay, x minus 1, okay, therefore x minus 1 is one of the factor of Px. Okay, so we already have one factor. We need to find the other factors. Okay, so let's try the other number. Okay, let's say if x is equal to negative 1. Okay, so substitute x with negative 1 into the given polynomial. We have here 1 minus 1 minus 7 plus 1 plus 6, is it right? 6, 7, 8 minus 8 is 0. So we can make a conclusion. Okay, therefore x plus 1 also factor of the polynomial. Okay, now we have two factors. Okay, which is the first one is x minus 1, the second one is x plus 1. Okay, this is the polynomial of degree 4, means we should have 4 factors. We already know 2 factors. Okay, to find the other 2 factors, okay, all we need to do is we can run a long division or comparing method. Okay, here I proceed with long division. Okay, before that, okay, let's find the divisor. So divisor here is equal to, okay, both factor. Okay, x minus 1, x plus 1. Okay, as pen here we have the our divisor is x square minus 1. Okay, so next proceed with a long division. Okay, x power 4 plus x power 3 minus 7x square minus x plus 6. Okay, divide by x square minus 1. Okay, so x square times x square, here is x power 4, right? Okay, so x square times negative 1 is negative x square. Okay, subtract, we have here 0. X power 3 minus 0 x power 3 is x power 3. Here we have negative 7 minus 1 is negative 6x square. Okay, bring down negative x plus 6. Okay, so x square times what equal to x power 3? X square times x, right? So here we have x power 3. X times negative 1 is negative x. Okay, subtract. Okay, we have 0 here. Here is negative 6x square plus 6, right? Negative x minus x is 0. Okay. Next, proceed with long division. X square times what here equal to negative x square, negative 6x square. So x square times negative 6 is negative 6x square. Okay, negative 6 times negative 1 is positive 6. Okay, so we will have no remainder. Okay, next proceed rewrite into a general form of the polynomial. Okay, therefore x power 4 plus x power 3 minus 7x squared minus x plus 6, okay, is equal to qx. Okay, what is our qx? Qx is x squared plus x minus 6 times divisor. Divisor is x squared minus 1. Okay, from here we need to factorize. Okay, factorize completely before we can find the roots. So if we factorize here, we have x times x is x squared. To have a negative 6, so this is 3 times 2. Okay, so this is positive, this is negative. And to factorize x squared minus 1, this is actually, we already know the factor is x minus 1 and x plus 1. Okay, so x minus 1, x plus 1. So here is our completely factorized of the given polynomial. Okay, next we want to find the roots. Okay, the question asks us to find the roots. So what are the roots? Okay, therefore the roots are, can you identify what are the roots? Okay, the roots are, okay, just take each factor and equal it to 0. So x plus 3 equal to 0. So the roots are x equal to negative 3, x equal to 2, x equal 1, and x equal negative 1. Okay, that's all.